Hello guys, today I will discuss partially square structural equation modeling part 3. Yes, I will discuss how to analyze data using smart PLS software, and I used the software to write dissertations. If you missed my past videos, please click the link here. First, I'm going to explain about the methodology. Then second, I will show you step by step on how to use the software. Instruction to run the software. In terms of reporting, partially square SEM can be divided into two parts. The first part is the report on the outer or measurement model. The second part is the report on the inner or structural model. I have previously discussed how to report Cronbach alpha in my last video, in which higher alpha values above 0.7 indicate a greater reliability and internal consistency among items measuring latent constructs. Today, I will show the following example. Using PLS SEM to investigate X as the latent construct of customer satisfaction, Cronbach alpha for X was calculated at 0.863. This high alpha value demonstrates strong internal consistency among indicators of Q21 to Q25, which support the reliability of the scale in measuring the latent variable of customer satisfaction. Now I will discuss the average variance extracted, or AVE, as part of the inner measurement model. The AVE is a measure to assess the variance captured by latent construct relative to the amount attributed to the measurement error. It helps to evaluate the convergent validity of the indicators of survey questionnaire or the observed variable associated with a particular construct. The AVE represents the average amount of variance that the indicators explain about their latent constructs. The AVE should be greater than 0.5 to demonstrate that more than half of the variance in the constructs is captured by its indicators. This indicates a robust convergence validity. Below are examples of how to report an AVE in your dissertations. The AVE for the latent variable of brand loyalty was computed at 0.637, being higher than 0.5 threshold of good convergent validity. This finding indicates that approximately 64% of the variance of the latent construct is explained by its indicator. This reflects a good convergent validity of the measurement part of the PLS SEM. Today I will also discuss the inner structural model, focusing on diagnostic statistics such as path coefficient and R-squares. Path coefficient is also known as beta weights, which represent the strength and the direction of the relationship between latent constructs and the structural model. The significance level associated with path coefficient are: the first one is p-values, the second one is t-statistics. If the p-value is less than 5% or t-statistic is higher than 2, indicates a very significant finding, while R-squared indicates the percentage of variance in the endogenous or dependent constructs, sales success that is explained by the independent constructs. Higher R-squared close to 1 signifies a better fit, explain a large proportion of the variability of the dependent constructs. Below are some examples of how to report beta weights and R-squared in your dissertations. The path coefficients from the latent constructs X to the latent construct Y was found to be 0.5 411 with a p-value being equal to 0.083, indicating a slight significant positive relationship at 8%. The path or coefficient from the latent construct Z to the latent construct Y was found to be 0.546, p-value less than 5%. Significant relationship at 2%. The R-square for the latent construct of sales success was calculated as 0.879. This indicates that about 88% of the variance of sales success is explained by the exogenous construct like customer satisfaction and brand loyalty. These findings highlights strong explanatory capability which validates the relevance of the partial least square structural equation modeling to explain, to predict the latent construct of sales success index. Okay, I'll see you in the next session.